Good morning to all the students out there. So in this 8th semester, I'm handling this elective course Advanced Construction Technology. So let me just quickly give you an outline about this course Advanced Construction Technology. So the first unit or the module of this course is Specialized Construction Techniques. So here in the slide, you can see the tentative course plan which I have prepared to cover the various topics of this unit. So let me discuss one by one. So in the first part of the lecture, we will be discussing about a specialized construction technique which is called as the box pushing, as well as we will be discussing about the box type retaining walls. And in the second part of the lecture, we will be discussing about an interesting technique which is called as the slip form, and it is used in the construction of high-rise structures such as chimney and silo construction. And in the third part of the lecture, we will be discussing about how the diaphragm walls are constructed and what is sheet piling, what are the different types of sheet piling, and what are the methods for driving the sheet piles. And in the fourth and the fifth part of the lecture, we will be discussing about the different types of the caissons, and also we'll be discussing about what are the advantages and disadvantages of each type of the caissons and its construction methods and procedures along with the sequences. And in the sixth part of the lecture, we will be discussing about underpinning, so which is a technique which is used for strengthening the existing buildings. And in the seventh part of the lecture, we will be discussing about two techniques that is called shotcreting and guinetting, and we will also be understanding what is the differences between shotcreting and guinetting and what is the construction process involved in these two techniques. And in the eighth part of the lecture, we will be discussing about vacuum dewatering methods, as well as we'll be discussing about the finishing and curing methods. And finally, to end with, we'll be just doing a refreshing of all the techniques, whatever that we have learned under the unit 1 or the module 1, and we'll be having a discussion about all these techniques. So this is the tentative course plan to cover this first unit or the module. So to start with, in today's lecture, we will be discussing about this technique called as the box pushing, as well as we'll be discussing about the box type retaining walls. So to start with, let me give an introduction about this technique that is called as the box pushing technique. So we all know that in the present day, everywhere, the intensity of the traffic is very high. Whether you take a roadways or the railways, everywhere the traffic is very high. The reason is due to the fast development of industries and in other infrastructures. So as a result, we cannot disturb the structures such as the structures as well as the roadways and railways for the construction of the bridges or the canal crossing, drainages, etc. by the conventional methods like the open cut system. I hope you all know what is this conventional or the open cut system. So this is nothing but you are cutting out the entire project site, that is you do the excavation, open excavation, and then you go for constructing the structures. So if you do the construction of the structures like that, then you have to supposed to divert the roads and the railways, and which will take a long time. So but that is not possible. So that is why we have to look for some advanced or some specialized techniques to do the construction. So to address this sort of issues in our country, the Noida authorities have come up with implementing a method called as the cut and cover method. So this method is implemented with the help of the technique that is called as the box pushing technique. Even in Delhi, that is in the DMRC, that is Delhi Metro Rail Corporation, while they were constructing the metro structures, they adopted the same technique, that is box pushing technique, by which they have avoided large scale digging process at their project sites. So this DMRC have used RCC boxes, that is reinforced cement concrete boxes, which are pushed with the help of hydraulic jacks in order to create a subway tunnel. So on the right side of the slide, you can see a very good picture of a metro tunnel, that is a subway tunnel, which is constructed by this technique, that is box pushing technique. And this is a short clipping which I have taken from a technical article which talks about the advantages of this box pushing technique. So let me read out what was given in the technical article. It says, as per the box pushing technology, the vertical excavation or large scale digging is not required. 6 reinforced cement concrete boxes are pushed with the help of the hydraulic jacks to create the 48-meter long subway tunnel. So DMRC have used this box pushing technique for creating the 48 meters long subway tunnel with the help of hydraulic jacks. So now let me move on to the next slide. So if you see what we do in this technique is, like you can see in this picture, that is, you can see in this picture this RCC boxes which are shown here. So these RCC boxes are cast outside in segments and they are pushed through the heavy road embankments or railway embankments, what you see in this picture, by jacking the required truss bed. So in this technique, the line and the level of this precast boxes are also controlled. So the main purpose of this box pushing technique is to make you can see like this sort of horizontal opening inside the ground. So you can see this is the horizontal opening inside the ground through the embankment by providing this sort of the precast box units underground without disturbing the overhead amenities like the traffic and various structures. So the advantage of this box pushing technique is there is no disruption in the traffic movement, whether it is a roadway or the railway, so it results in better quality control. So this technique is very much economical and the time for the completion is very less, and also you can see a lot of savings in manpower and machinery, and most importantly there is no involvement of the cranes and heavy machineries. And let us understand the procedures of box pushing techniques. Say this method of box pushing consists of construction of the truss bed as you see in this picture, and then we have construction of this is the construction of truss bed. Then we have construction of the precast RCC box segments over the truss bed, and then it's the installation of the front cutting shield, intermediate jacking stations, and pushing operations of precast box units. So all these boxes are designed and constructed at the site itself. It takes about 21 days to cast one box. So now we'll try to understand what are the components of each this box stacking techniques. So the first component, it is the truss bed. So let us understand what is this truss bed. See, a properly designed RCC truss bed should be casted at the appropriate location as you're seeing in this picture. So generally, the top layer of 50 mm is finished with a screwing layer in order to get a perfect level surface. So this truss bed also has, it has got the trussed walls and the shear keys, and they form the base for casting the box segments, and this also enables the jacking of the segments. So this trussed bed, they act as a medium for transferring the entire jacking forces into the ground. Sometimes it is also necessary to construct the auxiliary truss beds, so depending upon the site requirements, which in turn also helps in saving the materials like reinforcement, time, labor and expenditures. And here in the picture, you can see clearly the plan and the sectional view. This is the plan and the sectional view of the trussed bed. So this trussed bed consists of, you can see this is the trussed wall in the plan and this is in the section, and also it will have the shear keys as you're seeing here, and this shear key, it will be there, and the trussed bed will have this sort of the pin pockets on the B on this trussed bed, and also it will have this sort of the shear keys for giving the additional resistance. So the basic feature of this trussed bed is to give the necessary resistance which is needed for the pushing operations or jacking operation. As I told you before, the trussed bed will have shootable pockets at different locations for inserting the jacking pins, which are designed for resisting the pushing forces which are exerted by the hydraulic jacks as the boxes are being jacked through the embankment. So over the truss, as I said, 50 mm screening layer will be done to give the exact line, the level of the bed for the pushing operations. And at the pocket locations, the precast cover blocks are provided to cover the pin pockets during the pushing operations. So the second step is box casting and pushing. So in box casting and pushing, the RCC boxes are cast in segments of convenient length and pushing lengths. That is, they are cast in the segments of convenient lengths of total pushing lengths. So you can see the plan and you can see the sectional view of box segments. So the box sections are designed as per the IRS or IRC codes of practice for loading, and this concrete grade is normally kept as M30, and here you can see the plan view. So this is the top slab, that is the top slab of the box, and these are the side walls of the box where these are the side walls of the box, and this is nothing but the hydraulic jacks, or we can say intermediate jacking station. And if you look at the sectional view, you can clearly understand. So these are the trussed bed, and the trussed bed will have this sort of the pin pockets where you will be inserting the pin jacking pins, and you can see the steel pin is inserted inside this pin pockets, and you can see the steel plates are there, and the jacks are inserted between the rear end of the box and the steel plates. And this is the isometric view of this box stacking process, where you can clearly see these are the trussed bed and these are the pin pockets, and you can see the steel plates are there, and these are the hydraulic jacks, and this is the box. And the next one is front shield. So here you can see in this picture, this is called as the front cutting shield. So this is fabricated for the cutting action and to provide the supports and to prevent the caving in of the soil. So this front cutting shield, as you see in the sectional view, so this act as a cutting edge, and this will be provided at the front of the first box unit which needs to be jacked. So how it is fixed to the RCC boxes, it is through the proper anchorages which are provided in the box walls with the required projections from the face of the box. And if you see the sectional view, you can clearly understand this box itself is cast in a slope with a horizontal projection of required length, and this front cutting shield is given with a projection of around 1000 mm or more as needed, covering the entire periphery of the box. So the main feature of the cutting edge is not only to cut the soil but also to retain the soil above the cutting edge. So the next is rear shield. So like the front cutting shield, the rear shield is also fabricated from the mild steel, and it is fixed to the rear end of the box. So this shield will be fixed to the RCC boxes like through the proper anchorages in the box wall with a projection of around 400 to 600 mm. So this also covers the entire periphery of the box at the time of casting of the box, and generally it is provided with the anchoring steel plates on the face of the bottom slab of the RCC box for suitably distributing the jacking loads. So here you can see the pin pockets. So as I told you previously, so pin pockets will be there at the suitable locations on the truss bed. The size of the pin pockets are 0.5 by 0.5 by 0.6 meters, and they are provided at the suitable spacing for jacking arrangement. So the sides of the pin pockets are provided with the 6 mm thick mild steel plates to take up the truss. So the pin pockets are then it is filled with the sand and a small layer of the screed concrete in order to get a smooth surface